Okay, so today's problem focuses on a linear grading element, essentially this road. And the problem states that we have to grade the linear pathway that it slopes evenly between the two given elevation points, this and this, and has a 2% cross slope towards the bottom. So let's look at these 2 points first. This is a simple calculation. Before we jump into solving the problem, look at the problem first. So we have a few contour lines. Essentially, we'd have to regrade this site so that this contour might uh, change their form, and we have to create an even slope between this point and this point. And also, there's one additional extra step that this road towards the bottom would have a cross slope of 2%. So let's look at these 2 points, 225 and 230. So that's a 5 feet difference between elevation. Now we have to look at the total length between these 2 points. This drawing is 1:8. So if we are looking for 1:8 in our scale here, we would see that let's just create, this is the 0 right here. And if we are trying to measure this, if we align this scale perfectly, let's see that this is 84, then 85, then an 86. So the distance between this guy and this guy is 86 feet. So that is great. Now the total elevation difference was 5 feet. So how much difference we have between 1 feet contour elevation? So let's try to calculate that. So that would be 86 divided by 5. So between each point, we would have a 17.2 feet horizontal difference. So let's put it with our scale. Again, this was 1/8 scale. So this would be the right scale here. So here's 16, here's the 17, and then a little more, 17.2. So let's start putting those points right here. So yeah, 17.2 right here. And then one more. One more. One more. And hopefully this and this would be 7.2. Yeah, quite close. So these would be our different contour points. So if this is 225, 226, 227, 228, 229, and there's a 230, which is great. Now for the calculation of slopes, we know the equation kind of looks like this. If this is the vertical difference, which would be difference in elevation dE, and this is the total length, which would be L, our slope equals dE divided by L, which could also be said as rise over run, but we will keep talking about the dE by L in this exercise. So let's try to look at this. We have a 2% cross slope towards the bottom. So, and we also know the L, the width of the slope is 12 feet. So for this, we know slope equals 2%. We know L equals 12 feet. We don't know the DE. Okay, so let's calculate the DE first. So from this, we can say 2% equals DE divided by 12 into 100. And remember, whenever we are talking about a percent, we'd also have to multiply the total with 100 so that it remains a percent. So we can say that DE equals 2 into 12 divided by 100. So let's calculate for that. 2 into 12 divided by 100. That's 0.24 feet. So whenever we are calculating anything from here to here, we'd have to have less than 0.24 in this. So let's try to see how that looks like. So if we are drawing a complete vertical line from here to here, use this scale. So complete vertical line. This point would be 225 minus 0.24. So this would be, let's see, 225 minus 0.24, 224.76. Now the question is, where would be the 225 line? So that would be an interesting question to ask. We know that this difference is 17.2. So we can determine the road's slope this way with this. So let's do this calculation one more time, but for the length of the road this time, not the cross slope. This was the cross slope calculation. But to get the actual position of the 225, we'd need to get the slope in the length direction. So for the length, we know for each 1 feet elevation difference, that would not be L, DE, for each DE, the L would be 17.2. So let's calculate the slope. Because we want percent, we'd calculate it with 100. So DE is 1 divided by 17.2 into 100. So 100 divided by 17.2. So that is 5.81%. Awesome. Now we have to calculate the 225 with this slope. So let's try to calculate that. I'll get rid of my scale now. So for 225 at the bottom, DE would be 225 minus 224.76, which is 0.24. We don't know the L, but we know the S is gonna be this 5.81%. 5.81%. So let's calculate the L. We know S equals dE by L into 100. So 5.81 equals 0.24 divided by L into 100. Therefore, L equals 0.24 into 100 divided by 5.81. Let's calculate that. So that is 4.13. So now we can safely say that 225 elevation point for the bottom portion of the road is going to be 4.13 feet towards the right. Let's do that. 4.13. So 1, 2, 3, 4, and a little more. All right. So this would be 225 for the bottom portion. Now we could do this. We could just draw one vertical line and do like 4.13 for each of these points. But we already know the slope is going to be consistent, which is 5.81. So that makes difference between each point a 17.2 feet. So let's do that one more time. So 17.2, 17.2. 17.2, 17.2. I think I need one more. 17.2. So that would be the lower portion of the road. So 225, 226, 227, 228, 229, and 230. Now that we have calculated the elevation point for both the upper portion and lower portion of the road, the contour lines need to have a smooth transition between the existing and the newly drawn contour line. So I will do just that. I will create somewhat of a distance between the actual road and the point we will start to create the grading from, and we will learn more about this in near future. But right now, let's say this is the distance that looks okay for a smooth transition. I will draw it from each of the existing contour lines, and I will create the same difference between the bottom part. And now I'll just draw them smoothly, and I'll speed this part up. So for the first part, it goes over here, then comes back, then goes. It's important that these remain straight because this is a mechanical road. So essentially, I need to draw connection points between these guys. So that would be the 225. 226. I need to connect them with a straight line and then make the rest of them smooth. Now rest can be freehand drawings. So I'll just connect them. So that's it. That's how you do a simple road grading.